गुड मॉर्निंग। कल वाले सारे क्वेश्चन हो गए? कर रहे? क्यों नहीं करे? 5 ही तो दिए थे यार। अच्छा, ओके। आप पहली बार आए हो? पिछले वाले लेक्चर्स देखे आपने? अच्छा, तो थोड़ी सी डिफिकल्टी आपको हो सकती है। आप पहले वाले लेक्चर देखोगे तो सब क्लियर हो जाएगा। Yesterday we were talking about powers or exponents. Powers were nothing but repeated multiplication. Whenever we wanted to write 2 into 2 into 2 into 2, we simply wrote it as 2 to the power 4. We called it as a base. We called it as exponent or power. And then we went on to study squares and cubes. How to square or cube into some numbers from 1 to 30 and cubes from 1 to 15. I hope you have memorized the list. Then what else we did? We talked about what is the units place of square. Which digits cannot come at the units place of a square. That we talked about. Today we want to, then we saw few rules about powers or exponents. For example, whenever we have a raised to m into a raised to n, it was a raised to m plus n. And because division is nothing but opposite of multiplication operation, a raised to m divided by a raised to n was a raised to m minus n. Then another important one was a raised to m, उसका power n was equal to a raised to mn, right? Then we had a raised to 0 is equal to 1, a raised to 1 is equal to a raised to minus 1 is 1 by a. Whenever we had negative, we brought that into 1 upon in the division. Then we had a raised to 1 by n as a root of a, nth root of a. And in general, a raised to m upon n is equal to nth root of a raised to m. These were the rules with which we had to solve. There were a few homework problems. सबने किए होंगे, I hope. आपने किए? नहीं? एक रहा है. Online students, yesterday's homework problems. Were you able to do it? Yes, you could do all the problems. Any issue in any of the 5 problems that were given? Any issue in any of the 5 problems that were given yesterday? No problem. आपने किए कल के प्रॉब्लम्स जो 5 हमने दिए थे? नहीं किए? क्यों नहीं कर रहे हो यार? करो. You should do. Then we talked about what was that the units place of powers of 2. Then we talked about what determines the units place of any power. It was only the units place. For example, whatever is here, it didn't matter when we took any power. What mattered was only this digit, because how the multiplication happened. So whenever we repeatedly multiply this number with itself, what would be at the units place? 1 into 1. So 1. We again multiply new number by the same number. At the units place, we still have 1 into 1, 1. And rest of the places, there would be zeros and ones, and then we finally add. That is how we multiply. So only the digit at the units place determined what is at the units place of a power. That is something we concluded yesterday. Then we saw what would be there at the units place of number ending with 1. Number ending with 1 will have, we are taking any random power. what would be at the units place? For 1 it will always be 1. For 2 it will always be, we are at to see. Again we have to see what happens when we take powers of 3. Powers of a number ending with 3. That we'll see just now. What happens when we have a number ending with 5? No. Any power of number ending with 5, it will always be ending with 5. 5 into 5, 5 into 5, 5 into 5. Any number of times you can do 5 into 5. You will still have 5 at the units place. Number ending with 6. 6 into 6, 36. 6 into 6, 36. Again 6, 6, 6, 6. So it will always end with 6. Number ending with 7. We have not seen this. Number ending with 0. 0. This much we have seen. Right? Now, we firstly do 2 and 3. Then we will see what is happening at 4 and. Yes, we are still left with 4 PYQs. I remember, let us first finish this exponent part of the booklet, and then we'll go back to our 4 remaining PYQs from the last section. Okay. Now what we want to say, what we want to comment on is what happens at the units place when we take powers of 2. And we have seen only thing that matters is what is at the units place. So any number ending with 2, these numbers play no role in determining कि units place में क्या होगा. बस ये 2 मैटर करता है. तो हम इसको इग्नोर ही कर रहे हैं. अभी बस 2 को देख रहे हैं. मैटर ही नहीं करता तो क्यों देखे उसको फालतू. So just tell me what happens when we take powers of 2 at the units place. Again, we are just talking about units place. 2 raised to 1. What is at the units place? 2. 2 raised to 2. 4. 2 raised to 3. 8. 2 raised to 4. 16. 2 raised to 5. 2 raised to 5 is 32. So end with 2. 2 raised to 6. 64 का 4. 2 raised to 7 is 128 का 8. 2 raised to 9, 128 into 2. So 256 का 6. Are you able to see the pattern? 2486, 2486. Again you will multiply this 6 by 2. So 2 into 6, 12 का 2 आएगा उधर end में. So powers of 2 repeat in the blocks of 4. ये 4 का ब्लॉक रिपीट होता रहेगा हमेशा. ठीक है. So if I want to find out what is at the unit place of, let us say 2 raised to 17, then what do I have to do? I have to see 17 कहाँ पे आएगा ऐसे. Where would 17 lie when I repeatedly write this kind of thing in the blocks of 4? So 4 यहाँ पे आ रहा है, 8 here, then 12 here, 16 here, and 17 would be first here. So 2 raised to 17 would end with 2, right? If I have to calculate what is happening for 2 raised to 14, again I'll do 4 here, 8 here, this is 8, 12 here, then 13 and 14. So what is happening for 2 raised to 14? 4 at the end. ठीक है. Another example, if I want to calculate 2 raised to, let us say 30. If I want last digit of 2 raised to 30, again 4, 8, 12, 6, and we do something like that. 4, 8, 16 in the table of 4, we get in 28. For 28 it will be 6, then 29 and 30. ठीक है. What are we essentially doing? we are dividing this power by 4 and finding out the remainder, right? We are dividing this 30 by 4 and finding out the remainder. Remainder is 2. So we go 1 and 2. Or whatever is there, we take this as a units place. Why we are dividing the power by 4? Because these things are repeating in the blocks of 4. 4, 4, 4, 4 ऐसा repeat हो रहा है. I just want कि whenever I divide any given power by 4, where does the remainder lie? If remainder is 1, this is the last digits. If remainder is 2, this is the last digit. If remainder is 3, this is the last digit or units place. And if remainder is 0, this is the units place. That is what we do. And why divide by 4? Because ये repeat blocks of 4 में हो रहा है. No other reason. अगर ये blocks of 3 में होता तो 3 से divide करके remainder check करके. अगर 2 से होता तो 2 से divide करके remainder check करते. Whatever number of elements are there in this repeated block, we have to divide by that. वैसे वैसे उतने उतने जा रहे हैं ना हमेशा. Whenever we had to check for 2 raised to 17, we had to check where does 17 lie when we repeat this block of 4. So 4, 4, 4, 4 and next one. That is how we divide. We divide bigger number into those many blocks. We divide the bigger number into the blocks having size same as divisor, and then whatever the extra is there, that we call as remainder. That is what we have to find out. What is that extra? What is that remainder? ठीक है. Now on the next page there is a question of this year's CSE 2023. आपके पास बुकलेट नहीं है? ओके, तो आप किसी के उनके साइड में शिफ्ट हो जाओ. इट विल बी इजियर फॉर यू. आप भी शिफ्ट हो जाओ कहीं पे तो उनके साइड में. This year's question, CSE 2023. Question is, what is the units place of this particular number? 5, 7, 2, 4, 2 raised to 9 into 7 into 5 into 3 into 1. This is the question. Again, this is some random number. This is some random power. No examiner in their right mind would actually require you to calculate this manually. So there has to be some pattern. And what is the pattern? We have seen this is the pattern. What matters for the units place? Only these 2 matters. Other digits are random. You might as well put 50 more digits. I don't care about that. Tell me what is at the units place. Everybody calculate what is at the units place of this particular number. आज ये 2-3 बुकलेट लाएंगे क्या ऊपर या फिर उनको भेज दो. ये वाली? हाँ, मतलब फाउंडेशन वाली नहीं, सीसेट फाउंडेशन वाली अरिथमेटिक 1. ठीक है, बड़ी वाली बुकलेट है. हाँ, 2 लोग. ठीक है, नहीं होगी ना ऊपर पड़ी हुई या फिर इधर, तो दे देना. So what is the answer? 2. Who else has different answer? आपका क्या है? 2 आया. जमीर आ गया 2 पक्का. What we have to do? We have to find out what this number is and we have to divide it by 4 and check what is the remainder. That is the method. What is this? multiplication. This is 945. 5 into 3, 15 into 7, 105 into 9, 945. So 945 we divided by 4 and check what is the remainder. 944 is divisible by 4, the remainder would be 1. So if remainder is 1, last digit is 2. Then it is 6. Can remainder be 4 when we divide by 4? Remainder will be 0, 1, 2 or 3. No, multiply. Acha, different question. Right. Right. But this question is different, na? Question is about multiplication. अगर addition वाला question होता तो आप सही है. This is about 2 raised to 945. The multiplication is different. तो आप क्वेश्चन ही डिफरेंट ले रहे हो ना, पर वो तो कोइंसिडेंस से 2 आ रहा है क्योंकि ऑप्शन 4 ही वैसे भी कितना ही आएगा. But here the question is of multiplying these numbers. Fairly easy multiplication that we have to do, and just divide by 4, see the remainder and see where this particular remainder lies. For you too, I'll repeat what we did. We were yesterday talking about what happens at the unit place of a power. Right? We talked about what happens at the unit place of square and numbers ending with 1, 5, 6 and 0. That we did yesterday. Whenever we take any power of number ending with 1, unit place will always be 1 because we'll just multiply 1 to itself, 1 into 1, 1 into 1. If we have 5 at the end, unit place will always be 5 because number ending with 5 into number ending with 5. So 5 into 5, 25. So if we multiply this new number by old number, again 5 into 5, 25. So whatever number of times you multiply number with itself, it will always end with 5. Similarly, if we have number ending with 6, it will always have 6 at the unit place. 6 into 6, 36. Again set 36. At the end we have 6 and we are multiplying this number by a number ending with 6. 6 into 6, 6. So we multiply any number of times, we will end up with number having units place as 6. Similarly, number ending with 0 will always have 0 at the end. And then we were talking about what happens when we take powers of 2. Powers of number ending with 2. Whatever number we have and we are taking any power, only the 2 mattered. These digits were immaterial. You can put any numbers there because only the units place determines what happens at the units place of a power. So we ignored rest of the number and we took powers of 2. We wanted to check what happens at the unit place. 2 raised to 1, units place was 2. 2 raised to 2, units place was 4. 2 raised to 3 is 8, units place is 8. 2 raised to 4 is 16, units place is 66. Again 2 raised to 5, 32, units place is 2. 64, 4. 7, 128, 8 and 256, 6. So powers of 2, we found that they are repeating 2486, 2486, 2486 like that. In the blocks of 4, the powers of 2 are repeating. So if we want to find units place of any number or any power, what we want to do, we just want to check where does that power lie in this pattern. 2486, 2486, 2486, 2486. This pattern is repeating and we just want to check where does this new power that we want to find out lies. In case we want to find out 2 raised to 14, we will come till 2 raised to 4, 2 raised to 8, 2 raised to 12. 2 raised to 12 would have 6 at the end and 13 and 14. So we are at units place 4. If we have 2 raised to 30, 4, 8, 12, 16, 20, 24, 28 and then 2 are remaining. So we are at 4. 2 raised to 17, 4, 6, 4, 8, 12, 16 and 1 is remaining. So units place is 1. So what we have to do? We just have to divide this particular power by 4 and check what is the remainder. Because we are dividing this bigger number, bigger power number and seeing where does it lie when we divide this power by in the blocks of 4. Why blocks of 4? Because these numbers are repeating in the blocks of 4. Unit place is repeating in the blocks of 4. So when we divide any number in the block of 4 and check the remainder, if remainder is 1, this is the unit place. If remainder is 2, this is the unit place. For the remainder 3, this is the unit place, and for remainder 0, this is the unit place. Whenever we divide by 4, remainder can be 0, 1, 2 or 3. Yes. Last digit, only unit place. So you'll have to find pattern for second last digit and check the same thing. Sometimes it happens, sometimes it doesn't. For powers like for 25 it happens. What would be 25 square? 625. What would be 625 square? Some 625 into 25. 25 5. Again 25. So there is pattern for second last digit as well. No, sometimes there is. I mean, it is not that there is. For example, if we take 20, at the end we have 20. This would be 400. Then, so this is the one pattern, and then we have zeros like this. This is also some kind of pattern. It is not important. ये पूछा नहीं जाता है. But whenever they ask you new question, it will be one very easy, and secondly it will be pattern based. Just see the pattern for first few digits, first few numbers of the same type, and you will establish the pattern in the examination hall. That is how you are supposed to do. ऐसा नहीं हो सकता कि सारे pattern हम अभी से पढ़ लें. But those which are frequently asked, which we should know, that we will do, and based on that knowledge, we will extrapolate whatever question they give us. Then we did this PYQ, which is on the next page. They are asking units place of this particular number. And what we know, only these two matters whenever we are talking about units place. Other digits are irrelevant. और आगे 50 नंबर जोड़ दोगे तो भी कोई फर्क नहीं पड़ेगा. So we are concerning about 2 raised to something, units place of 2 raised to something. How do we find out? We find out this number, we divide it by 4 and find out the remainder. So what is this number? This number is 945. That multiplication we have to do. This is not very difficult. This is just 945. We divide it by 4, find out the remainder is 1. And because remainder is 1, the units place is 2. Answer is A. It was as simple as that. और कुछ नहीं करना था इस क्वेश्चन में, इतना ही करना था. Very standardized question. These are the kind of question that we must target. If there are new kinds of question which require us to think very analytically in exam hall, they are perhaps time consuming. But this kind of question which are very standardized, अभी यही करना है, ये तुम्हें पता है, और कुछ नहीं करना था. Whenever number ends with 2, we just have to divide the power by 4 and find out the remainder. इतना ही करना होता है. And same is the story with 3. Now, what happens with 3? We have any number, it ends with 3 and we are taking any power. What would determine the units place? Only 3 would determine the units place. Rest of the numbers are irrelevant. कुछ फर्क नहीं पड़ता. क्यों नहीं पड़ता? Because this power is nothing but repeated multiplication. And if we multiply this number by itself, only units place would be determined by this 3 into 3 only. Rest of the things do not matter. Again, if we multiply new number by old number for taking cube, then what matters? Only this matters. Rest of the things do not matter. That is why we are talking about only units place whenever we are talking powers. Reason भी थोड़ा सा पता होना चाहिए. Why only the 3 is being considered? Because that is how we multiply. Only units place determines units place of power. Tell me what happens at the units place of powers of 3. 3 raised to 1, 3 raised to 2, 9, 3 cube, 27 का 7, 3 raised to 4, 81 का 1, then 3 raised to 5, 243 का 3. Anyway, we can also talk about if you multiply this number 80 here 81 by 3, 3 into 1 3. Units place to units place से determine होता है. That is how we are basing our argument. Then 3 raised to 6, 3 into 3. Guess कर सकते हो क्या होगा अभी? Same story, exactly same as what was happening for 2. Repeat would be 3971, 3971, 3971. This is how powers of 3 will repeat. Any doubt? This is how powers of 3 will repeat. Now, what will we do when we have to find out what is the units place of, let us say 3 raised to 70. We'll divide this 70 by 4. We'll check the remainder, and wherever the remainder lies, that would be the units place. What is the remainder? 68. 4. 17 4 the 68. Remainder is 2. If you are not able to visualize it, do this. Find out the remainder and answer correctly. इतना ही करना है. Then 3 raised to 400. What would be the units place? 1. This is divisible by 4 clearly. So units place is 1. I can give you any number, let us say 52. Let us say 52. What is the units place? 1 again. This number is divisible by 4. We are yet to study divisibility test of 4. But how do we check if any number is divisible by 4? We just look at last 2 digits. If last 2 digits are divisible by 4, then we say that number is divisible by 4. That is the divisibility test of 4. We'll study it in this booklet only. So this number is divisible by 4. So remainder is 0. So unit place is 1. This is how we'll comment for 2 and 3. Any doubt? For 2 and 3. Number ending with 2 or 3. Any doubt? No doubt. Pakka. This question is repeatable. This can come as it is in examination hall. This year they ask for a number ending with 2. Next year they might ask for number ending with 3. It is possible. Comfortable in this? Pakka? Okay. Now look at your booklets. There are few questions that are given. In the same section, units digit in exponent. Page number 13. After the rules, we have few questions. Just tell me what would be units place. First question is 125 raised to 4. 5. Second question, again 5. Doesn't matter how big the numbers are. What matters is only units place. So 5 होगा उसका. Third question, 12 raised to 33. What is the remainder? Remainder is 1. So units place is 2. Right. Next question. Next question, 1, 2, 2, 3 power 45. What is the remainder? 45 का remainder 0 कैसे होगा? 1. So power would, units place would be 3. And last question. Right. Sunil, you are right. Last question of that list. 0. How? We have 1 2 2 3. What is the units place of this? 3 raised to 45. We calculated na just now. 3 for this. For this 4. Remainder is 2 na. So 4. So our basic calculation was based on units place of power is only determined by units place of whatever is there at the base. But why was that? Because that was how we were multiplying units place. We were just multiplying units place with itself. Now these are also units places of these numbers. So units place of a product would be determined only by multiplication of these units places. What is the multiplication? 5 into 4? 20 का क्या आएगा? 0. And here 0 into 3 again 0. So units place of a multiplication is nothing but multiplication of units places. We'll just find the units places and multiply them. ठीक है? Any issue? Right. सुनील ये कौन सा सिंबल? अच्छा ये 0. Right? 0 is correct. ठीक है? Comfortable? Pakka? Whenever we have to take product, we just multiply what is at the units place. Comfortable? Everyone? Online students, all are comfortable with whatever is happening at the units places of when we take powers. Are you guys okay with it? We can extend this for other powers. If I take powers of, let us say, number ending with what is remaining? 4. So let us say 4. Let us see what if there is some pattern or not. 4 raised to 1, 4, 4 square, 6, 4 cube, again 4, again 6, 4, 6, 4, 6. So we have a pattern and repetition in blocks of 2. So if the power is even, we'll have 6 at the end. If power is odd, we have 4 at the end. As simple as that. Then what else? 7. 7 से पहले 9 लिख लेते हैं. 9 is again easy. 9 raised to 1 is 9. 9 square, 81. 9 cube, 729. So again 9, again 1, again 9, again 1. For even powers, we'll have 1. For odd powers, we have 9 at the end. So anything that you can think about can be anything that is asked in the examination hall. You can firstly try to gauge the pattern and solve the question. Similarly, 8. Can we do something with 8? 8 raised to 1, 8 square, 64, 8 cube, so 2. I am just multiplying the units place by 8. I don't need a bigger number. यही होगा. अब खत्म. Again we have pattern in the blocks of 4. Same thing would apply. Divide the power by 4 and see where the power lies. But something again another thing you can do, if you have 8 raised to, let us say 110, you can write it as 2 raised to 3 raised to 110 and 2 raised to 330 and solve the question for 2. So that is why we don't need to study 8 separately, because we can convert it into base 2. That is why we may not need to study 4 separately, because we can convert it into base 2. So 2 और 3 पढ़ लिया, तो बाकी भी powers पढ़ लिए, जैसे कि 8, 4, 9. We don't need to study them separately. but if you want, you can write the pattern for them as well. Now finally 7, we don't know if the pattern is there or not. We'll try to see if there is some pattern. If not, 7 would be exception. 7 raised to 1, 7 square, 7 cube. Just multiply this number by 7 and you will get the unit place. बन रहा है? Again, in the blocks of 4, we are getting the pattern. Okay? हाँ. We are just multiplying with itself. I mean, this is how we multiply, ना? Multiplication की वजह से हो रहा है. 7, 7, 9. 7 into 9. वैसे हो रहा है. What we'll do? We'll divide 7 ka power, whatever is there in the power, by 4. Check the remainder. If remainder is 0, ending with 1. If 1, 7, 2, 9, 3, 3. Clear? Fine. And if there is mixture, we'll individually calculate the units places and multiply. If there is product of 2, 3 different powers, individually calculate units place, multiply and check what is the units place at the new number or the product of multiple numbers. ठीक है, चलिए आगे. Last thing that we want to do in this section is take exponents and roots with decimal points. If we have 1.2, or just say, what is 0.2 square? 0.2 into 0.2 is equal to what? How do we multiply two numbers of having decimal point? We multiply as if there is no decimal point and then add total number of digits after decimal point. 1 plus 1, 2. So यहाँ पे we should have 2 digits after decimal point. So we have 0.04. This is how we multiply decimal numbers, 2 decimal numbers. If I have 0.02 square, what will have 0.02? What will it be? We'll multiply 2 into 2 first, so we'll have 4. But how many decimal points? 2 here and 2 here. So 4 digits after decimal point in the product. So we have 1. So we need additional 3. This would be it. Right? If I have 1.2 square, which is equal to 1.2 into 1.2. What is? Let us first forget the decimal point. We have 12 into 12. 12 square is 144. And how many decimal points? 1, 2. So here. This is how we multiply two numbers having decimal points. Square is nothing but number multiplied by itself. So we are just adjusting our basic rules for that. Okay. If I have 0.012 square, it will be बताओ. Okay. So we have 3 digits here. So when we multiply number by itself, we need 6 digits after decimal point. 3 we'll get from 144. So we have to add additional 3 zeros. So we have 0, 0, 0, 1, 4, 4. ठीक है, कंफर्टेबल. वी आर जस्ट मल्टीप्लाइंग, नया नहीं है. वी आर जस्ट मल्टीप्लाइंग टू नंबर्स विथ डेसिमल पॉइंट. व्हाट इज हैपनिंग इज, यहाँ पे here we had 1 after decimal point, there we have 2, here we have 2, there we have 4, here we have 1, we have 2, 3, 6. Of course, you are multiplying number by itself. So whatever digits, number of digits there are after the decimal point, they would be doubled when we take square, right? Whenever number is doubled, here we'll always have even number of digits after decimal point, because we are multiplying by 2 na every time. So here we cannot have 5 digits after decimal point. We need to have 6 if we are squaring. समझ रहे हो? थोड़ा appreciate हो रहा है. Here we have 2 digits after decimal point. There we have 4, because number we are multiplying with itself. We have a 2 digits after decimal point. We are multiplying it by itself, मतलब squaring. So we are having 4 digits after decimal point there. Here we have 3 after decimal point. So we get 6. 3 plus 3. बीच वाला तो skip हो गया ना, इसके और इसके बीच में 4 था, यहाँ पे 6 हो गया. 5 कभी नहीं हो सकता. That is what I'm saying. Let us take few more example. 1.2 square, we talked about it. It is 1.44. 0.12 square, it is 0.0144. And 0.012 square is equal to 0.00144. Same number. I am just shifting the decimal point. Here I have 1 digit after decimal point. We have 2 zeros. 2 digits after decimal point. 2, 4, 3, 6. Yeah, if I have, how many numbers would be there in the decimal point? After decimal point, 8. Out of which 3 are 144. So we have to add 5 zeros from our side. ये होगा, ठीक है. Right? This is what we call squaring a number. On the other hand, what would be square root? Forget about negative sign. Plus minus होता है square root में. But if we talk about only positive square root, then we'll say इसका square root ये है. Square root of 1.44 is 1.2 by definition. अगर 1.44 is square of 1.2, then 1.2 is square root of 1.44. That is by definition it is happening. Right? Or square root of 0.0144 is equal to 0.12. Now question is, what is this? Hmm? 0.12 का स्क्वायर तो ये है. This is different number. That is something I want you to take note of. इसका स्क्वायर रूट निकालना इजी बात नहीं है. It is not easy to find out square root of this particular number. We can only find out square roots easily when we have even number of digits after decimal point. क्योंकि स्क्वायर रूट में वो आधे हो जाते हैं. अब 3 का आधा तो 1.5 नंबर तो हो नहीं सकता डेसिमल के बाद, तो इजीली नहीं कैलकुलेट होता है. ओके. If we have 4, you can simply have 2 there. If you have 2, you can have 1 there. If you have 6, you can have 3 there. But if you have here 3 digits after decimal point, you cannot calculate it easily. इसका आंसर कुछ और है. Your calculator will give you answer, but that would be something different. Not so easy like 1.2 or 0.12, etc. Okay? हाँ. हाँ कर लो. This would be 144 divided by 1000. ठीक है. So 12 आ जाएगा बाहर. So it will be 12 into square root 1 by 1000. 100 into 10 हो सकता है, बिल्कुल हो सकता है. 100 into 10. So ये 10 बाहर आ जाएगा. So we have 12 by 10 root of 1 by 10. This is not easy number. This is not 0.12 or 0.02, 1.2 or 0.12. It is not that. It is a different number. It is in fact irrational number. है ना, ये irrational number है ये. This is not easy number. So that is something to take note of. We can take square roots easily only when we have even number of things after decimal point. Why? Because any number we are squaring, we are doubling the number of digits after decimal points. यहाँ पे हमेशा even आ रहे हैं. यहाँ पे 2 आए, 4 आए, 6 आए, 8 आए, बीच वाले नहीं आए. राइट? क्लियर? समझ रहा है? पक्का? या बस हाँ में हाँ मिला रहे हो? हाँ, क्लियर? पक्का? हाँ में हाँ नहीं मिला रहे ना बस. राइट, राइट सुनील. It was in fact an irrational number. This is irrational number. Whatever we have done for squares, we will do same thing for cubes. What happens when we cube numbers with decimal points? That is something we want to check. So tell me 0.2 cube. It is nothing but 0.2 into 0.2 into 0.2 by definition. इसमें कोई प्रॉब्लम नहीं है. This is the definition of cube. What is this? This is just our old multiplication. We forget the decimal point. We multiply 2 into 2 into 2. We get 8. And how many? Where should we put decimal point after 1, 2, 3? Right? 0.008 आएगा. Then what would be 0.02 cube? This would be 0.02 into 0.02 into 0.02. Again 2 into 2 into 2 is 8, and 2 plus 2 plus 2, 6 digits after decimal point. 8 we have. We need 5 more digits. So we have 5 more zeros. 1, 2, 3, 4, 5 and 6. Right? Tell me this 1.2 cube. Huh? Right? Do you guys know Hardy-Ramanujan number? Hardy-Ramanujan number or taxi cab number. Have you heard this story? There is a story of Ramanujan, everyone knows, right? Ramanujan was one of the greatest mathematicians that India has ever produced. He was 20th century mathematician, self-taught. I mean, he had no access to any kind of resources. He was self-taught. When he was in school, he used to study higher standard mathematics books and just study on his own, derive his new results. And his entire works are concentrated in his 2 to 4 diaries. And these diaries are so hard to decrypt that mathematicians are still trying to understand what is he trying to say. And now, after so many years, there is actual chance that some of those equations that he wrote, some of the results he wrote could help us in quantum computing, in building quantum computers and so on. So he was well, freak of a nature. We do not know how he came about those results. And what happened? He was in Tamil, he was as a teacher, he was working in Tamil Nadu, and he was unrecognized. So he had no resources. He was extremely poor, but still a genius. So with help of few friends, he sent his work, some of his work to London to Professor G.H. Hardy. He was a very renowned mathematician of the time. He found the work and he was astonished. Some of the work he already knew, that it has been proved, but many of the results were new. Ramanujan, of course, didn't know that इसमें से कुछ result prove हो चुके हैं. He had no access to what is happening at the mathematical world. So Hardy was astonished. He called upon Ramanujan. He gave him funding and finances and called him to London. So Ramanujan worked with Hardy for many years in London, but Ramanujan was pure vegetarian guy. वहाँ पे ना उनको climate suit हुआ, ना उनको food suit हुआ. So very naturally he suffered through multiple ailments. And one such time he was in his hospital bed and Hardy went to meet him. And ऐसा बोला जाता है कि Hardy went to meet him and Hardy said कि I came via cab, but cab had very weird number. I just didn't like it. So Ramanujan asked, why? What was the number? Why do you think it was such a way? No, I just didn't like the number. I got uncomfortable seeing the number. So Ramanujan asked, what is the number? So Hardy said 1729. Ramanujan immediately replied that this is a beautiful number. Why? Because this is the smallest number, which is sum of cubes of two different numbers. It is at the same time 1 cube plus 12 cube, and it is at the same time 9 cube plus 10 cube. You can verify. What is 9 cube? 729 plus 1000. So this number 1729, and this is 1 plus 1728. Again 1729. So Ramanujan immediately replied that this is the smallest number having this property, and that is why this is very beautiful number. And Hardy later commented that every number was his personal friend. So he was just like that. Again, I don't know if you have read this in current affairs, but there is fields. What are you? Yes, Man Who Knew Infinity. There is a movie after him. So beautiful movie. Again, something you could watch. In current affairs, you might have come across this Ramanujan algorithm. Mathematicians or scientists in Israel have developed this Ramanujan algorithm, or something as Ramanujan software or something like that. What it does is, if we usually how mathematics works, you have a problem and you try to solve it towards the solution, right? You have a problem and you try to solve it. But Ramanujan didn't need to solve it. He just wrote the results from somewhere. We don't know how he came about those results. Of course, correct results, accurate results. Many of them are proven. Many of them are still remaining unproved. But he just wrote the result. Yeah, this is true. Then mathematician used to ask him, how? How do you know this is true? No, I know this is true. There was no explanation with him that why this is true. And when Hardy asked him, he said that goddess Namagiri comes in my dream and tells me this beautiful result. So again, some say he was freak of nature, some say he was genius of different level, and so on. But many of his results remain to be proved. And this software that I was talking about, this algorithm, what it does is, it goes in the reverse direction like Ramanujan. You give problem, you get solution usually, but it gives you solution. If you give the software solution, it will try to frame the problem in the reverse direction. What is its solution? Yes, I have also seen this movie called Beautiful Mind. It stars Russell Crowe, no? Russell Crowe, I think, is there, and he plays again mathematician John Nash. John Nash was again of the similar stature, similar level as Ramanujan. Again, freak of nature. We don't know how these people used to do things. There is also another quote about Richard Feynman. You might have heard about him, Richard Feynman. And there is this book that Surely You Are Joking, Mr. Feynman. It is his autobiography. And there, one mathematician has talked about him, or one physicist, I think, that there are two kinds of geniuses. One who work very hard, who work so hard and achieve so much that they become geniuses. Those kind of geniuses leave you room to believe that if you work hard enough, you can achieve what they have. And then there are magicians. You cannot achieve what they have because you just don't know how they do it. And Feynman was a magician. In the same line, we can say Ramanujan was a magician. We don't know how he did what he did. But yes, you can also watch Beautiful Mind by, it is on the mathematician John Nash. Surely You Are Joking, Mr. Feynman. It is on Ramanujan. Then another movie on Alan Turing. There is another movie. I don't. Do you remember the name of the movie? Right. The World War II context. Huh? Enigma. Right. Enigma. That is another movie. Yeah. Cubes of these two numbers. Smallest such number which has two such pairings that add to, when we cube, add to 1729. This is called as Hardy-Ramanujan number or taxi cab number. Okay. If you watch some such good movies, it is not entirely against your preparation because you can give its references in your essays. It comes off as very beautiful if you can pull it off. Otherwise, stories and all, everybody has started to write. It gets extremely boring. If you have ever evaluated essays or seen essays of other people, you will see that it is extremely boring to read those irrelevant stories that students have started to write based on previous toppers' experience. So if you can instead write about such movie references which are actually good movies and it hits the topic, it comes off as very, very beautiful. Book references, movie references, those come off as very beautiful. Yes, Imitation Game, not Enigma. Imitation Game. Imitation Game was the machine का नाम Enigma था. Right. German machine जो था. Right. Machine, उसका Imitation Game नाम था. Imitate किया ना. Right. Book references, movie references, those work really fine in essays if you can pull it off. Context सही होना चाहिए बस. And कैसे use करना है? I don't know if you have read this, but our Foreign Minister S. Jaishankar has written this book on India's foreign policy, and this is how he starts the book, with movie reference. He says that the film of famous Satyajit Ray film of 1960s portrays two Nawabs playing chess while East India Company take over their wealthy and mighty kingdom of Awadh. This, and then he says that this beautifully portrays Indian ignorance and unawareness about what is happening around them, self-absorption, and conclusion is we cannot be self-absorbed anymore. We have to engage at the global level. If we can use such movie references, it comes off as very, very beautiful. But ऐसा नहीं होना चाहिए कि 2 पेज तक movie में ही लिख रहे हो. Of course, that's given very crisply, very shortly, very impactfully. You can write in 1 paragraph. That comes off as very good. अगेन मूवी ऑल्सो ऐसी होनी चाहिए, ऐसा नहीं कि कोई रैंडम ऑब्सक्योर मूवी दे दो जो उस एग्जामिनर ने भी कभी नहीं देखी और उतनी अच्छी भी नहीं हो. तो ऐसे मत देना कि कोई एकदम ही वरुण धवन की मूवी का रेफरेंस मत देना. in this year's essay, I have given one book reference of, I wrote the essay on mathematics. It was mathematics is the music of reason. So I started with, there is very famous book by Douglas Hofstadter called Gödel, Escher, Bach. Gödel was a famous mathematician and logician. Bach, as you know, was a musician, and Escher was a scientist or philosopher. Not scientist, philosopher. So he amalgamates all these disciplines into one. This was the core theme of the essay was that reason, music, mathematics, they are all stemming from the human capacity to reason. That is how essay was portrayed. So I started with that book, and in that book he discusses what is mathematics and how it is about patterns and how music, how reason is origin of mathematics, etc. etc. 155 मिलेगा मुझे, अच्छा ठीक. मैं इतना इजी होता तो क्या चाहिए था. Anyway, point is you can use these movie references, book references in your essays very beautifully if you can pull it off. ऐसा नहीं कि जो भी कर रहे हो, मतलब whatever you are doing outside preparation as well, that also becomes relevant if you can use it wisely. अपनी आंखें खुली रखो and सब हो जाएगा. लिखो. हाँ, लास्ट ईयर जो द हैंड दैट रॉक्स द क्रैडल रूल्स द वर्ल्ड, वो ना. हाँ, अच्छा. अच्छा, नहीं इसमें राइट रॉन्ग कोई है ही नहीं यार. इट इज अबाउट यू हिटिंग द टॉपिक. नहीं नहीं ठीक है, गाली गलौज से फर्क नहीं पड़ता. इट इज मोस्ट प्रोबेबली उसने नहीं देखा होगा, है ना. फैमिली मैन तो नहीं देखा होगा, तुम्हारा जो इंग्लिश का प्रोफेसर होगा 70 साल का. सो इट इज अबाउट व्हाट यू राइट देयर. अब देखा होगा तो ठीक है, देखा होगा, वो तो उसको पसंद भी आया होगा तभी देखा होगा, तो माइंड भी नहीं करेगा. बट मोस्ट प्रोबेबली तो नहीं देखा होगा. नहीं देखा होगा तो जो तुम लिखोगे, इफ इट हिट्स द कंटेक्स्ट देन इट वर्क्स. इफ इट हाँ कोई बात नहीं. हाँ, नो प्रॉब्लम, नो प्रॉब्लम. बस वो कंटेक्स्ट फिट होना चाहिए, बाकी कुछ प्रॉब्लम नहीं है. कोई फेमस लिखते हो तो उसके लिए भी आसान हो जाता है. अब अगर ऐसी मूवी लिखोगे जो सबने देखी होगी, दंगल, 3 इडियट्स, लगान, लिख लो, कोई प्रॉब्लम नहीं है. या फिर कोई हॉलीवुड की लिखनी है वो लिख लो, कोई फेमस बुक्स लिखनी है वो लिख लो, फेमस पोएम्स, रॉबर्ट फ्रॉस्ट वगैरह की पोएम्स लिख लो. 4-4 पेज लाइंस की पोएम्स होती है. जस्ट नोट देम डाउन समवेयर एल्स एंड मग अप. हाँ, क्रिस्टोफर नोलन लिख लो, क्या प्रॉब्लम है. Many times if you plot the last 5 years essays na, you will see that there is one essay that is occurring frequently is ideal versus reality, science, reason versus philosophy. हाँ, मतलब some reason versus philosophy. ये थीम जो है ना रिपीट होता है. साइंस एंड आर्ट, ये थीम रिपीट होता है, साइंस वर्सेस आर्ट. तो इफ यू रिमेंबर द essay, history is series of victories of scientific man over romantic man. So we have scientific man, we have romantic man, and we have to talk about their interaction or throughout the history. That is one. So this kind of topics are repeatable. तो ये तुम्हें देखना है कि लास्ट के 5 साल में what number of topics have repeated. एकदम पॉपुलर थीम्स होते हैं, उस पे ऐसे आता है in 1 or 2 years. Wisdom, truth, humility, ह्यूमैनिटी, देख लो 5 साल की निकाल के देख लो. मटेरियलिज्म वर्सेस आइडियलिज्म. वांटलेसनेस, द गोल ऑफ वांटलेसनेस इज यूटोपियन बट मटेरियलिज्म इज काइमेरा. व्हाट इज इट? ऑन वन हैंड वी हैव मटेरियलिज्म, ऑन अनदर हैंड वी हैव आइडियलिज्म, वांटलेसनेस व्हिच इज यूटोपिया. आइडियल वर्सेस मटेरियल, ये थीम वेरी वेरी रिपीटेबल, हर साल आता है. देख लो 5 साल निकाल लो, कम से कम 3-4 ऐसे मिलेंगे. तो अगर इतना रिपीटेबल टॉपिक है दैट यू शुड हैव कंटेंट प्रिपेयर्ड ऑन इट, लिखना ही चाहिए तुम्हें उस पे। और अगर आ गया बाय चांस वही ऐसे नेक्स्ट ईयर सम वर्डिंग चेंज करके चेप के आ जाओ, पूरा टाइम बचेगा, एफर्ट बचेगा, अच्छा ऐसे आएगा, सब होगा। वरना तो उधर बनाते रहोगे फिर। इस साल आ गए इजी टॉपिक्स, दिस ईयर्स ऐसे टॉपिक्स वर वेरी इजी। एजुकेशन पे ऐसे था, जेंडर पे ऐसे था, हर साल ऐसा नहीं होता। लास्ट ईयर टॉपिक्स वर क्वाइट डिफिकल्ट इन दैट रिगार्ड। तो वहां पे दो ऐसे बनाना फर्स्ट हाफ और 40 मिनट्स में, और फिर 3 घंटे में उन दोनों को अच्छे से लिखना इज नॉट एज इजी एज इट सीम्स। 3 घंटे में लिखना चैलेंज तो होता ही है अंडर एग्जाम प्रेशर। तो एंड में जो भी मन में आए लिख लेते हो, फिर ऑफ कोर्स मार्क्स आर डाउन। यार ऐसे के मार्क्स वेरी भी बहुत होते हैं, 40 to 140 कहीं पे भी आते हैं, और एक बार 40 आ गए तो रिकवर करना इम्पॉसिबल हो जाता है। तो इसलिए राइट, गेम ऑफ थ्रोन्स रेफरेंस, सम टॉपर्स हैव गिवन द गेम ऑफ थ्रोन्स रेफरेंस। ठीक है, मतलब गेम ऑफ थ्रोन्स भी रेफर कुछ भी कर सकते हो, बस कोई इलीगल मूवी जो इंडिया में बैन हुई है वो मत करना। दैट शुड बी, मतलब ये तो कॉमन सेंस है। इंडिया में बैन है तो देखी कहा भाई तूने, ये नहीं लगना अच्छे एग्जामिनर को। बाकी तो ठीक है, मोस्टली यू आर वाइज इनफ टू नॉट डू सम एक्सट्रीम थिंग्स लाइक दैट। गेम ऑफ थ्रोन्स वगैरह ऑफ कोर्स यू कैन रेफर, बट यूज इट इन राइट कंटेक्स्ट। ऐसा नहीं कि बस रेफर करने के लिए कर रहे हो, कुछ अगर सच में है तो करो। महाभारत की स्टोरीज, रामायण की स्टोरीज, इतना सब कुछ हम बचपन से सुनते हैं, पढ़ते हैं, वी कैन डेफिनेटली यूज इट। उपनिषद के कुछ श्लोक रट के जाओ यार, इट कम्स ऑफ एज रियली वेल। अगर तुम वो पुल ऑफ कर सको, बस वही लिख के आओगे तो कुछ फायदा नहीं है। बट इन ओवरऑल कंटेक्स्ट ऑफ द एसे, इफ यू कैन राइट समथिंग, if you can give references to Gita or some other holy books, Guru Granth Sahib, some saint poetry, मतलब कोई कबीर का दोहा लिख रहे हो, कई तुकाराम का अभंग लिख रहे हो, कई चैतन्य का कीर्तन लिख रहे हो, दैट कम्स ऑफ एज वेल, अगर सही कंटेक्स्ट में यूज करो तब। बस लिखने के लिए मत लिखना, बट यू आर वाइज इनफ। और ये सब फॉर्डर मटेरियल तुम जमा कर लोगे, वही कंटेक्स्ट एडजस्ट करने के लिए ही प्रैक्टिस चाहिए होती है कि कहाँ पे क्या यूज करना है। इसीलिए मैं बोलता हूँ कि एक वीक हर ऐसे लिखा करो, ये सब जमा करके लिखा करो। वॉट एवर टॉपिक यू वॉन्ट टू राइट, गैदर द फॉर्डर मटेरियल बिफोर हैंड एंड देन राइट, देन ऑल्सो यू विल फेस चैलेंज। हाँ, वो तो क्वालिफाइंग है उसमें। अरे क्वालिफाइंग पेपर को जितना क्वालिफाइंग पेपर डिजर्व करता है उतना टाइम देना होता है। वो तो 300 मार्क का पेपर है यार, यू जस्ट हैव टू गेट 75 मार्क्स। मेरा मराठी, यू जस्ट हैव टू गेट क्वालिफाइंग मार्क्स देयर। 100 मार्क का ऐसे होता है, देन देयर इज प्रेसिस, देन देयर इज ट्रांसलेशन। हाँ हाँ, बहुत नहीं करना पड़ता, बहुत नहीं करना पड़ता। It is not as difficult as it sounds. It is very easy. The last 50 marks is of, हाँ ideally, अगर तुम्हें 150 मार्क चाहिए तो, पर चाहिए तो 75 ना, तो मैनेज करोगे तो भी हो जाता है वो, है ना? आपने तो किया भी है। अच्छा, ओके फाइन। बहुत लोग करते हैं, ऐसा कोई चैलेंज नहीं है। इट इज जस्ट थोड़ा सा 1 घंटा देना पड़ेगा रोज, इससे ज्यादा क्या होगा। वेन एवर इन द लास्ट मंथ ऑफ मेंस, मतलब लास्ट मंथ बिफोर मेंस, थोड़ा थोड़ा टाइम देना पड़ेगा। अभी से वरी करने की जरूरत नहीं है हिंदी की। दिस इज समथिंग अभी से वरी करना है, क्योंकि इसके मार्क्स काउंट होने, वरना तो इसके बारे में भी नहीं करते। फाइन। We talked about cubes and then we'll talk about cube roots. Same story as what happened with square and square roots. What would be cube root of 1.728? 1.2, right? Here there are 3, here there is 1, because here there is 1, we got 3, here 2, we got 6, 1, 3. If we have 0.012 cube, ये क्या होगा? How many digits would come after decimal point? 9 would come, because here there are 3. So 3 in this is multiplied 3 times. So 3, 3, 3, 9 digits would come after decimal point, out of which 4 are 1728. So we need 5 additional zeros. ये होगा. So what we can observe is, whenever we are cubing, whenever we are finding out cube of a number having decimal point, number of digits after decimal point will always be 3, 6, 9, 12, etc. बीच में नहीं हो सकता, right? It will always be 3, 6, etc. Why? Because we are multiplying 3 times. उतने बार तो आएगा ही, 3 के multiples में आएंगे ही. So same story, whenever we are finding out cube roots, we have to see how many digits are there after decimal point. If there are in multiples of 3, then you can find out the cube root easily. If it is 0.008, we see that there are 6 digits after decimal point, so we can find out the cube root easily. Cube root would be 0.02, right? But what if we have something like this, 0.08? Can we find cube root easily? No, cube root बहुत difficult होगा इसका find करना. It would be in fact irrational number, like we had in earlier case. So this is not easy, because this is just 2 decimal points, digits, 2 digits after decimal point. We can write this as 8 into 8 divided by 100, which is 2. This cube root we are talking about. 2 into cube root of 1 upon 100, which is equal to 2 into cube root of 10 upon 1000, equal to 2 by 10 into cube root of 10. This is irrational number, not easy to calculate. That is the point. If we have 6, 3, 9, etc., then it is easy to calculate if the number is cube. Fine. ठीक है. Cube, squares, semi-famous fiction novel. Oh. Yeah, you can give, definitely give. But why? If the novel is not that well known, then you have to set the context. In the famous novel, by this, named this, this is what is happening in one line, and then you can talk. You can comment on whatever you want to. That way we can do. Just like I talked about that Dr. S. Jaishankar, he just talks about that in a famous Satyajit Ray movie, there are 2 Nawabs playing chess. He set the context in one line, and then his point was, we cannot be self-absorbed anymore. Indian self-absorption is very famous, but we cannot be self-absorbed within itself, because our external factors do affect us. Even if we choose to ignore them or not, they do impact us. That was his point which he conveyed. So essay, you can set the context and write whatever you want. Okay. Any problem in this section? Powers. Any problem in powers? No problems. Clear? पक्का? चले आगे. आगे मतलब पीछे जो अपने 4 क्वेश्चन छूटे हैं वो पहले करेंगे. We are yet to do 4 questions from PYQs of last section. Page number 10 पे आ जाओ. Page number 10, question number 4th from top. Consider the following multiplication problem: PQ into 3 इज इक्वल टू आर आर क्यू, वो वाला करना है. वी हैव पी क्यू इंटू 3 इज इक्वल टू आर क्यू क्यू. We are given r not equal to 0. P, Q, R are different digits. Question is, what is P plus R divided by Q, I think. Right. Try it out. गलत आ रहा है तुम्हारा. Somewhere you are making mistake. क्या बताओ? बाकी लोग ट्राई करो, ये गलत आंसर है. यू कैन ट्राई इट आउट. पी कितना? These are single digits. Yes, Ashwini, that is correct. क्या है पी क्यू आर? हाँ, मतलब क्या है वैल्यूज ऑफ पी क्यू आर? पी इज व्हाट इज वैल्यू ऑफ पी? तो 2 कैसे आया आंसर? देयर इज यूनिक आंसर हियर. P is unique, Q is unique, R is unique. Your final answer of this is 2. That is correct. But वो कैसे आया? That is something I am asking. क्या है D? नहीं. हाँ हाँ. क्या आया? 85 इंटू. हाँ, तो डालो ना पी आर और क्यू. ये फाइंड करना है. वी हैव टू फाइंड आउट विद दिस वैल्यू. P plus R is 10 divided by Q. अच्छा, यस यस. सिंपल मल्टीप्लिकेशन करना है. हाँ, आ गया. क्या आया आपका? वी हैव टू मल्टीप्लाई 3 बाय Q. हाउ डू वी मल्टीप्लाई? इसको यूनिट्स प्लेस से करते हैं, वो इधर लिखते हैं, एंड वी कैरी फॉरवर्ड समथिंग, देन इसको P से करके ऐड करके लिखते हैं फाइनली. दैट इज हाउ वी मल्टीप्लाई. So we want a number Q such that 3 into Q is giving Q at the end. 3 into Q should give Q at the end. 3 into 1 3 देता है, तो वो नहीं है, 1 आना चाहिए था ना. यहाँ पे और यहाँ पे सेम आना चाहिए. ऐसे डिजिट हमें ढूंढना है है ना. 3 into 2 6 not allowed. 3 into 3 9 not allowed. 3 into 4 12, यहाँ पे 2 आएगा not allowed. 3 into 5 15 allowed. 5 5 आया. If 3 into 5 5 gives. So Q can be 5. We have to look for other chances as well. 3 into 6 18 8 not allowed. यहाँ पे 6 और 8 आ रहा है. We want same digit here and here. अगर आपको ऐसे orally difficult हो रहा है तो just write down. Take Q as 1. So 3 into 1 3. 2 3 4 5 6 7 8 9 and 0. Right? And just multiply by 3. कहां पे मैच हो रहा है? यहां पे और यहां पे सेम कहां पे आ रहा है? एक यहां पे आ रहा है और एक यहां पे आ रहा है. राइट? इफ यू आर अनएबल टू डू इट ओरली, जस्ट राइट इट डाउन. आंसर सही आना ज्यादा इंपॉर्टेंट है. ठीक है. So we have two alternatives for Q. Q can either be 5 or Q can either be 0. कैसे आ गया समझ गए? Let me keep it there. Now we'll take two cases because we have two possibilities for Q. If Q is 0, we have P0 into 3 is equal to R0 0. Right? Or I can write this as P0 into 3 is equal to R0 0. Right? Fine. Basically, this number is divisible by 3. Right? This is something into 3, so this is divisible by 3. So our RHS will also have to be divisible by 3. LHS is divisible by 3. So RHS also will have to be divisible by 3. समझ रहे? So what can be this R for this to be divisible by 3? 369. So it can be either 300, 600 or 900. Now this two-digit number into 3, can it ever be 300? 100 into 3 होता है ना 300. तो two-digit number into 3 तो 300 हो ही नहीं सकता. इसलिए we reject that case. So क्या बचा? 5 बचा. So we have P into 5 into 3 is equal to R 5 5. So 3 5s are 15. Carry 1. 3 into something plus 1 के एंड में 5 आना चाहिए. So it has to be 3 into P something plus 1. 3 into something के एंड में ये आता है, उसमें एक ऐड करोगे तो 5 आना चाहिए. So कहां पे आ रहा है? 4 plus 1 5 आता है. So it has to be 8. So this comes out as. So we have your values of P, Q and R, which we can put in the required expression and find out the answer. ठीक है? समझ गए? जमीर? पक्का? We have to do no fancy stuff. We just have to multiply as we usually do. Units place को units place से multiply करो. Just check what are the possible values of Q. They are either 5 or 0. So we make two cases. One case is with 5, another case is with 0. And for 0, we conclude that because this number cannot be divisible by 3 unless R is 300, 600, 900, R is 369, which is not possible because two-digit number into 3 cannot be larger than 300 or even 300. हाँ, कैसे? यहाँ पे P 4 होगा तो 3 into 4 12 plus 1 plus 1 12 plus 1 13 का 3 आएगा ना फिर इधर. We want 5 there. इतना ही करना है. Just we have to multiply and see कौन से नंबर मल्टीप्लिकेशन से फिट होते हैं. ठीक है? UPSC is not expecting us to be masters in mathematics or do any fancy stuff. They want us to do basic stuff better way. We are just through with the problem of PQ into 3 RQQ. वो सब लोग समझ गए. Multiplication वाला problem everybody understood, right? We are now at the next problem. Next question. Question is, we are given a long multiplication and we have to find out how many zeros are there at the end of that product. Now, what do we mean by zero at the end? How many zeros are there at the end of this thing? 2 zeros are there. 2 zeros meaning 215 into 100. 100 is nothing but 10 square. So whatever is power of 2, that many zeros come at the end. If we add 3 more zeros, what do we have? 215 into 1 followed by 5 zeros. I can write it like this. This is nothing but 215 into 10 to the power 5. Right? Whatever power of 10 we have maximum in the product, those many zeros are at the end of the product. So finding out number of zeros at the end is fancy way of asking कि 10 की कौन सी maximum power product में आ रही है. This is just a fancy way of asking what is the maximum power of 10 that is there in our product. That is what we have to find. What is the maximum power of 10 that can come in our given product? And power of 10 is nothing but 2 into 5. If you want to find 10, we have to find 2 and 5, and they have to be together for it to be 10. That is your hint. You have to find 2, you have to find 5 in the product. Product क्या है? In this product, you have to find out how many times 2 appears and how many times 5 appears. Yes, that is correct. Other students, Yashraj, Sunil, you guys also solve. If you guys want to interact, you can let me know. I have the headsets and we can talk. If you have any doubts, any comments, we can interact. Okay. क्या आया? 10 आया. ओके आपका हाउ मेनी टाइम 5 अपीयर्स वो गिन सकते हो? 5 अपीयर्स हाउ मेनी टाइम्स? ठीक है, ठीक है, ठीक. और 2 कितनी बार आ रहा है वो गिना? तो 4 बार ही 10 आएगा. 6 + 4 10. गुड, राइट. आपने को 5 हाउ मेनी टाइम्स अपीयर्स वो कैलकुलेट किया. इसमें 7 ही बार आ रहा है. 5 क्या बात कर रहे हो? 5 ज्यादा नहीं आ रहा. 5 हाँ इस मल्टीप्लीकेशन में आफ्टर रिमूविंग 10 ना. आई एम लेट अस सी यहाँ पे एक बार आएगा. राइट. टोटल या 0 हटाने के बाद टोटल नहीं आएगा. देखो एक 5 एक बार यहाँ पे आएगा 5 में, फिर 10 में एक 5 छुपा हुआ है, 15 में एक 5 छुपा हुआ है, यहाँ पे एक 5 छुपा हुआ है, यहाँ पे देयर आर 2 5s हियर, 25 is 5 into 5, यहाँ पे एक 5 छुपा है, यहाँ पे एक, यहाँ पे एक, यहाँ पे एक, अगेन 50 में 25 छुपा है, तो यहाँ पे 2, यहाँ पे एक, यहाँ पे एक. हाउ मेनी टाइम 5 appears, you can count? हाँ 5 55, 5 into 11 is 55 ना. हाँ एक बार 5 आ रहा है इसमें मल्टीप्लीकेशन में. 1 2 4 7 8 10 plus 4 14 times 5 appears, so it is basically 5 raised to 14. Now we'll calculate how many times 2 appears. First time 2 appears here, once, here twice because 4 is a factor, here once, here 8 is a factor, 8 is a factor na, here once and here twice. 2 plus 1 3 plus 3 6 plus 4 10. So how many number of times 5 and 2 can occur together? 10 times, क्योंकि उसके बाद 10 2 are over. So this is 2 raised to 10 into 5 raised to 14 into some other factors, which is equal to 2 raised to 10 into 5 raised to 10 into 5 raised to 4 into other factors. Now this is 5 into 2 raised to 10 into other factors. So this is 10 raised to 10. So number of zeros is 10. ये समझ गया? How many times 2 appears? How many times 5 appears? इसको now for this number I can write this. This number is nothing but 2 raised to 10 into 5 raised to 14 into some other factors that I am not interested in. Now I am just simplifying. I am separating 5 raised to 14 into 5 raised to 10 into 5 raised to 4 using our exponent wale rules. Now I am clubbing these two. 5 into 2 raised to 10 hai, and this is 5 raised to 4 into other factors. Now this is nothing but 10 raised to 10 into other factors. Now 10 raised to 10 matlab 10 times zeros would come at the end of the product. You can either directly calculate something like this, or you can do what she did. She separated zeros beforehand. So she calculated how many zeros are already there. So is 1, 2, 3, 4, 5 and 6. 6 zeros are already there. She calculated it separately. Then we'll remove it because we have calculated it. Right? ये किया, and now she calculates 2 and 5. How many times 2 appears? How many times 5 appears? Now 2 appears only 4 times, 5 appears 7 or 8 times. So again 2 would be the limiting factor. 6 plus 4 बार और 2 आएगा, तो 10 times 10 आएगा. Right? Any which way you can do. Again a very easy question. You just have to calculate how many times 2 appears and how many times 5 appears and see what is the limiting factor. Whatever lesser power is there, that many number of times 10 would appear. समझ गए? पक्का? पक्का? आपका नाम? निरंजन. आप समझ गए? जमीर? नहीं समझे? हमें क्या फाइंड करना है? हमें फाइंड करना है हाउ मेनी टाइम जीरो अपीयर्स एट द एंड ऑफ दिस प्रोडक्ट. ये बड़ा सा प्रोडक्ट दिया है, इसके एंड में कितने जीरोस आ रहे हैं. एंड में जीरो का मतलब क्या होता है? 10 कितनी बार आ रहा है उसमें. जितने भी बार 10 एज अ फैक्टर आ रहा है उतने बार जीरो आएगा एट द एंड. नाउ 10 क्या होता है? 2 into 5 होता है 10. तो हम क्या कैलकुलेट कर रहे हैं? 2 कितनी बार आएगा, 5 कितनी बार आएगा. तो हमने कैलकुलेट किया 5 में आएगा, 10 में एक बार आएगा, क्योंकि 10 क्या है? 2 into 5 है. 15 क्या है? 3 into 5 है, तो वहां पे एक बार आएगा. हाँ हाँ हाँ, वही कर रहे हैं हम लोग भी, बट हम 5 भी काउंट कर रहे हैं क्योंकि हमें पता नहीं कि कौन सा छोटा है। अगर तुम्हारा 2 10 आया और अगर 5 80 आता तो 8 बार ही 10 बनता, क्योंकि 2 5 और 2 दोनों भी साथ में चाहिए हमें 10 बनाने के लिए, तो जितना है ना, तो जो भी कम है उतने बनेंगे। 10 बार हमने यहाँ पे 2 यूज किया तो उसके बाद 2 खत्म हो गए हमारे, इसलिए 10 ही बने। अगर हमारे पास और 2 अवेलेबल होते तो और बनते 10, और यहाँ पे 2 कम है। अगर इन केस किसी और प्रोडक्ट में, हाँ, अगर फॉर एग्जांपल मैं इसको इनटू लेट अस से 128 कर दूं और इस प्रोडक्ट को, अब ये 128 क्या है, 2⁻7 है, तो 2 कितनी बार आता, 10 + 7 17 बार आता। अब कौन सा छोटा है, तो अब 10 कितनी बार बनता, 14 बार बनता, क्योंकि वो 14 बार यूज करके खत्म हो गया, पर 2 अभी भी बचा है तो वो बचा रहेगा। फॉर मेकिंग 10 वी नीड बोथ 2 and 5, वी कैनॉट डू only with 2 alone or 5 alone, we need both of them together, that is the point. Okay, understood. Next question, देखो क्या है। Again, before you attempt the question, this is the question which was to be left alone. This is very non-doable question in examination hall. You cannot do it. Very difficult. Many cases you have to consider, and something which you may not even, कुछ intuition भी आना पड़ता है, उसके बाद कुछ करके कुछ cases भी लेने पड़ते हैं. So it is a very long process in that regard. So again, something which you should avoid in examination hall. After था, ये तो PYQ है, वर्कशीट में नहीं होगा, कुछ और होगा क्वेश्चन वो। हाँ ओके, हाँ, दिस इज मॉडिफिकेशन, स्लाइटली सिंपलर मॉडिफिकेशन ऑफ द सेम प्रॉब्लम। हाँ हाँ हाँ, दिस इज डिफिकल्ट प्रॉब्लम। ट्राई करो फिर भी, बस मुझे ये बता दो कि तुम्हारा पहला इंट्यूशन क्या, पढ़ो क्वेश्चन और मुझे बताओ पहला क्या लग रहा है, क्या करना चाहिए। नहीं करना चाहिए तो ठीक है, वो आना ही चाहिए, बट पढ़ के क्या करना चाहिए वैसे। गुड इनफ, दैट इज व्हाट आई एक्सपेक्ट। इसके आगे नहीं हो रहा है, करना भी नहीं है, एक क्वेश्चन छोड़ देंगे, कोई बात नहीं। ये बहुत डिफिकल्ट क्वेश्चन था एग्जाम में करने के लिए। राइट, डेफिनेटली। बस वो पढ़ के क्या आपको फर्स्ट इंस्टिंक्ट आ रहा है वो जानना है मुझे, सो दैट यू आर गोइंग इन द राइट डायरेक्शन। आंसर नहीं आई इस क्वेश्चन का, कोई बात नहीं, नो दैट हैपेंस विद पावर्स। क्वेश्चन आप पढ़ो, वी हैव अ 3 digit नंबर with following characteristic. They have given some 3 digit number with some characteristic. They have not given which 3 digit number. So what do we assume? X, Y, Z. And whenever we do something like this, है ना, what are the characteristics given? All the digits are different. That is one characteristic. Second is the number is divisible by 7. Okay. And third is on reversing the digit, number is divisible by 7. So whenever we have a 3 digit number or 2 digit number and we reverse it and we apply something, some property on it, what do we do usually? कौन सा मेथड यूज करते हैं? Place values, right? That is what we do. That is what we have done until now. In every question, whenever they gave us random number without any warning, we just wrote that random number as XY or XYZ and expanded that number using place values. And plus they have given another hint कि reverse करके कुछ कर रहे हैं. So automatically this is based on place values. That is how we have to proceed. अब इसके आगे थोड़ा सा tricky है. We have a number XYZ is equal to 100x plus 10y plus z, and we are reversing it. Reverse करके क्या आएगा? zyx is equal to right. What we have is this is also divisible by 7 and this is also divisible by 7. That is given. Now what we use is whenever we have two numbers divisible by 7 or any number for that matter, then their difference is also divisible by 7. For example, I take any value. If number a is divisible by 7, then a can be written as 7 into some number k. A is divisible by 7 का मतलब होता है a is a multiple of 7, right? A is divisible by 7. A is divisible by 7 meaning a is multiple of 7. That is remainder is 0. Whenever we write it like this, remainder 0 होता है ना when there is pure complete divisibility. And if another number b is also divisible by 7, then it is also multiple of some multiple of 7, right? And if I take difference a minus b, we have 7k minus 7m, which is equal to 7 into k minus m. So this is also some multiple of 7. So a minus b is also divisible by 7. Whenever we have any numbers divisible by 7, right, the difference between the numbers is also divisible by 7. ये clear है कि नहीं? We have two numbers divisible by 7, so their difference will also be divisible by 7. Why? Because when number is divisible by 7, it means it is some multiple of 7. This is also some multiple of 7. So when we take difference, we get another multiple of 7. So difference is also some multiple of 7, meaning difference is divisible by 7. Question है सुनील, how many such numbers are there? तुम्हारा आंसर बताओ. Work it out and answer करो. Now why are we so interested in difference? Because when we take difference, ये 10y cancel हो जाएगा. Here also we have 10y, here also we have 10y, that will get cancelled and we'll have one less variable to worry about. That is why we are concerned about difference. So let us take difference. What we have, 100x minus x, so 99x, z minus 100z minus 99z, and 10y will cancel out. And what we have, this particular number is multiple of 7, because this is multiple of 7, this is multiple of 7, this is also multiple of 7. So this is 7 into something, right? Basically 7 divides this number, and this number is nothing but 99 into x minus z. 99 I can take common. So we have a product of two numbers and 7 divides this product. ठीक है? Does 7 divide 99? No. So 7 has to divide x minus z. 7 does not divide 99, na? So 7 has to divide x minus z. So what can x and z be? These are numbers, these are digits, pairs. It can be 92 or 81. X and z can be then 92 or 81. Of course, we'll reverse it. X, z we can interchange later, but basically there will be these two pairs. Correct? Now we only have two options. X and z, we have 92 or 81. So we have x, some y, z, and whenever we divide by 7, we should get remainder 0. अब हमें देखना है what is the possibility of y. Right? Now there are two ways again you can go about it. You can keep putting up values of y and see कि कहाँ पे divisibility आती है, or you can reverse engineer this process of long division और देखो फिर कहाँ पे divisibility आती है. First you can do on your own. कि यहाँ पे y की जगह 1 डाल के देखो, 2 डाल के देखो, 3 डाल के देखो, 4 डाल के देखो, and wherever you have remainder 0 that would be value of y. एक हो सकती है, मल्टीपल हो सकती है, you have to check that. ठीक है, समझ रहे हो ना? If you put 1, you divide by 7, you check if the remainder is 0 or not. अगर है तो that is acceptable. अगर नहीं है तो you have to move ahead. और y को 2 नहीं होना है because x, y, z are different. Then you can put y equal to 3, check. Y equal to 4, check. Okay? Or you can do this. We have 9y2 divided by 7. How do we divide? 7 ones are 7 minus 7 you have 2. ऊपर से क्या आएगा? y, right? So this is some 20 something. So you can have 7 3s are 21 or 7 4s are something 28. ऐसा आएगा. Then we'll subtract something. कुछ बचेगा और ऊपर से क्या आएगा? 2 आएगा. And we'll subtract and we should get remainder 0. तो यहाँ पे भी सेम चीज subtract होनी पड़ेगी जो यहाँ पे है. Because we are given कि this is divisible by 7 ना. ऐसा होना चाहिए. If this number is divisible by 7, लॉन्ग डिवीजन कर रहा हूं मैं, बस लेटर को मैं छेड़खानी नहीं कर रहा हूं, लेटर को वैसे रख रहा हूं. ऐसा होना चाहिए. इसमें कोई प्रॉब्लम है ना? अगर रिमाइंडर यहाँ पे 0 है और एंड में दोनों के 4 है एंड दिस इज मल्टीपल ऑफ 7 समथिंग जा करके ये सब्ट्रैक्ट होता है ना. तो इन टेबल ऑफ 7 वेयर डू वी हैव एंड में 2, 7 6 जा 42, तो दिस हैज टू बी 42. तो यहां पे भी 42 होना पड़ेगा, तभी तो सब्ट्रैक्शन 0 होगा. समथिंग माइनस टेबल ऑफ 7 रिमाइंडर 4 होना पड़ेगा, राइट? तो कैन इट बी 7 4s are 28 हो सकता है क्या इधर? फॉर हियर टू बी 28 यहाँ पे 32 होना पड़ेगा फिर, पर यहाँ पे 20 समथिंग है तो यहाँ पे 21 होगा, तो यहाँ पे 25 होगा. तो वी हैव अ नंबर 952. So we have one number 952, another number 259. We have to check क्या ये 7 से divisible है कि नहीं, because reverse also has to be divisible by 7. However, we don't know this y ना. That is one way. मैं ऑलरेडी बता दिया कि इधर you can put the values 1 डाल के देख लो, 2 डाल के देख लो, 3 डाल के देख लो, 4 डाल के देख लो. That is one thing you can do, or you can do this reverse engineering. Your call. दोनों भी कर सकते हैं. अगर ये एक बार समझ गए तुम कैसे कर रहे हैं तो ये इजी लगेगा, क्योंकि ये इसमें तुम मल्टीपल कैलकुलेशन करना नहीं है, इसमें एक ही करना. यहां पे देखो क्या है, वी आर गिवन कि फाइनल डिविजिबिलिटी है, रिमाइंडर 0 है ना, बिकॉज दिस इज डिविजिबल बाय 7, रिमाइंडर हैज टू बी 0. सो और यहाँ पे एंड में 2 आ रहा है, तो यहाँ पे जो नंबर आ रहा है वही यहाँ पे आना पड़ेगा, तभी तो रिमाइंडर 0 होगा. तो यहाँ पे भी नंबर 2 आना पड़ेगा, एंड दिस नंबर इज 7 समथिंग जा, एंड इन टेबल ऑफ 7 वेयर डज 2 अराइज? एंड में 42 में, तो इट हैज टू बी 4 हियर, तो इट हैज टू बी 4 हियर. एंड बिकॉज डिफरेंस इज 4, व्हेन वी सब्ट्रैक्ट दीज टू नंबर्स, some number in the table of 7 plus 4 has to be this number. So it is either 21 plus 4 or 28 plus 4. यहां पे हमारे पास ये था ना, इतना था हमारे पास. Here y was there ना. So and 2y minus something is 4, right? ये बाद में आता है ना ऊपर से, ये 2y minus something is 4. So this something has to be in the table of 7. ये table of 7 से आता है ना something यहाँ पे, तो it can be 7 or 14 or 21 or 28, etc. But here we have 20 something, na? 2y. So can it be 28? Because it will be then 28 plus 4, 32 होना पड़ेगा उसको. That is not possible. So it has to be 21. So 21 plus 4, it has to be 25. We are reverse engineering. I'll show you one more thing because we have to compute about this pair 8 and 1. एक और pair है ना हमारे पास. So we have 8 y 1 and we divide by 7. Now you guys will help me determine this y. Let us see if you can do the reverse engineering. Okay, let us try together. Firstly, we'll divide as we always do. We'll divide the first digit. 7 1s are 7. इसमें कोई issue नहीं है. So we'll have minus 7 and remainder is 1. Then 1 के साथ next digit will come y. 1y will be there, right? Divide कर रहे हैं हम लोग, ऐसे ही divide करते हैं हम. We'll take the next digit down and then something from the table of 7 comes. We subtract whatever we get here. Next thing 1 follows last digit, and because complete divisibility is there, the same number has to be subtracted and we get 0 as a remainder. Because it is given that number is divisible by 7, so remainder has to be 0. ये होना पड़ेगा पक्का. So because end में 1 है, तो ये क्या होना पड़ेगा? In the table of 7, 21 has to be there. So this has to be 21. So this has to be 21. So some 1y minus something has to be 2. So it is either 16 minus 14, right? 16 minus 14 or 11 minus 9, 11 minus 7 नहीं हो सकता ना. 16 minus 14 is the only option. 16 minus 14 and this has to be then 16. This has to be 6. So we have 861 and 168. Check if this is divisible by 7. It is divisible by 7. So how many numbers we have, which was the question? 1, 2 and 1, 2. So 4 is the answer. As warned, this was a long question, something which you should have avoided in examination hall. ठीक है. Did you understand this reverse engineering process of long division? Long division ही करना है, उल्टे डायरेक्शन में करना है. Now I want you to try few of these questions. I am making on my own. So अगर आपको आंसर नहीं मिलता है, that is possible. Find out the x such that this number is completely divisible by 11. Again, find out y such that this number is completely divisible by 7. If there are multiple possibilities, find them all. Yes. It may seem doable when I explain it, but when you don't have any external help, you will face difficulties because सब एक साथ करना is not easy. Parts of it you may do, but पूरा एक साथ उसी मेथड से exactly तुम्हें वहां पे क्लिक होना is something far-fetched a bit. But we have 80 questions. एक क्वेश्चन छूट भी जाए कोई बात नहीं. We'll attempt rest of the questions. There are many easier questions. 2 की पावर निकालने को पूछ रहे, 2 के पावर के एंड में क्या है, वो तो बहुत आसान है. There is a definite standardized method to do it. Find out these x, y, z such that the remainder is 0 in each case. Okay? Reverse engineering करते रहना. Don't put values. वो purpose नहीं है, क्योंकि purpose आंसर निकालना नहीं है. Purpose है रिवर्स इंजीनियरिंग का थोड़ा ट्राई करना. अगर नहीं निकले तो फिर वैल्यू डाल के चेक कर लेना. बट प्राइमरीली ट्राई टू रिवर्स इंजीनियर द प्रोसेस. इससे आपके लॉन्ग डिवीजन के भी कंसेप्ट क्लियर हो जाएंगे कि लॉन्ग डिवीजन होता कैसे है. क्वेश्चन तो बेसिक से ही आ रहे हैं. शुड वी मूव अहेड? अगला क्वेश्चन करें. लास्ट क्वेश्चन वेरी इजी, वेरी इजी, एंड दिस क्वेश्चन वाज रिपीटेड इन दिस ईयर्स पेपर. हाँ हाँ हाँ, राइट. This question was repeated in 2023 again. ये हमने किया था ना actually. We have done this question. Right. We have done this question. So you can refer to the old lecture on that day. Or for this particular question, this is very easy. You can just put values and check. But what is the correct way to do it? Mathematical way to do it that we have explained in previous classes. Please watch video lecture of that class. Next, prime numbers. क्या जाना है? अभी टाइम है 15 मिनट. Prime factorization will start tomorrow. Prime numbers is something we have already studied. You guys already know what prime numbers are. We are just refresher course की तरह इसे treat कर रहे हैं. What are prime numbers? Numbers which are divisible by 1 and itself. That is all. It has only 2 factors, 1 and itself. That is a prime number. Numbers which are not prime are called composite numbers. Prime numbers, composite numbers. And 1 is neither prime nor composite. 1 is unique. ठीक है? Every year in questions they talk about P is a prime number, C is a composite number, and they give you 3 statements and you have to comment on possibilities. So you need to know what is a prime number and what is a composite number. Prime number, उसके पास 2 factors है, 1 and itself. One solve along division. What do you want to say, Sunil? समझा नहीं मुझे. Yes, prime numbers only 2 factors, 1 and itself. Composite number will have 1 and itself as a factor, plus there would be some other factors. For example, we'll take 7. What are the factors of 7? Only 1 and itself. Only 1 and 7. So 7 is a prime number. But what about 9? What are the factors of 9? 1, 9, yes. But 3 is also a factor. So 9 is not a prime number. 9 is a composite number. 15. 1 is a factor. 15 is a factor. Plus there are additional factors 3 and 5. So 15 is a composite number. Composite numbers can be even or can be odd. Are all even numbers composite? Because 2 is always a factor. 2 is always a factor of any even number. Is that correct? Huh? For any even number, 2 is a factor. That is correct. So you take 4, 6, 12, 1, 2, 3, 4, anything. 2 is always a factor whenever number is even. So even numbers can never be prime except smallest prime number 2. 2 is a prime number. Why? Only factors are 1 and 2. 2 is itself, no? Only prime number which is even is 2. So if the question is, do we have even prime number? Yes, we have even prime number 2. What is smallest prime number? Again 2 is the smallest prime number. It is the only even prime number. ठीक है? Something which we already know. ठीक है? Now again one thing we should know, and this is again non-negotiable. We should know all the prime numbers from 1 to 100 because question have been asked. Question is asked this year itself. What are the prime numbers from 1 to 100? Tell me from 1 to 10. What are the prime numbers from 1 to 10? 2, 3. Yes, that is all. Even numbers तो इसके आगे देखेंगे ही नहीं. After 2, we don't have to worry about even prime numbers. Then from 11 to 20, 11, 13, 17, 19, 4 again. From 21 to 30, 23, 25 is not, 27 is not, 29, yes. From 30 to 40 is 31 prime number? Yes, कोई factor नहीं है 31 का. 33, no, 3 and 11 are factors. 35, no, 5 into 7. 37, yes. 39, no, 3 into 13. 13 3s are 39. Fine. Now 40 to 50, 41, 43, yes. 45, no, 9 into 5. 47, yes. 49, no, 7 7s are 45, 49. Now 50 to 60, 51, 3 into 17. 53, yes. 53, 55, 5 से divisible है. 57, 3 into 19. 59, yes. 60 to 70, 61, 63, no. 65, no. 67, yes. 69, no. 23 into 3. Okay, now 70 to 80, 71, yes. 73, 75, no. 77, no. 11 7. 79, 80 to 90, 83, 81 is 9 into 9. Then 85, 5 से divisible है. 87, 3 से divisible है. हाँ? 89, 89 is prime. From 90 to 100, 91, no. 93, 3 से divisible है. 95, no. 97, yes. 99, 11 into 9. So how many are there total? These are 25 prime numbers from 1 to 100. If you remember, in the brackets of 10, it is very easy to recall, right? अब वो question देखो तुम CSAT 2023 का. Choose the group which is different from choose the group which is different from the others. You will be able to do it only with observation if you know all the prime numbers from 1 to 100. Right? All the others are prime numbers except 1. Except 91, all are prime numbers. So correct answer is D. Very easy question. Was it difficult question? यही इसी साल का question. So there are enough easy questions for you to qualify. You just have to choose यू जस्ट हैव टू रीच टिल दैट क्वेश्चन. कहीं पहले अटक गए लास्ट क्वेश्चन वाले जैसे क्वेश्चन में तो प्रॉब्लम है. अदरवाइज इट इज देयर आर इनफ नंबर ऑफ इजी क्वेश्चंस फॉर यू टू डू. आंसर सिंपल है, बस ऑब्जर्वेशन से हो रहा है. 10 सेकंड में हो जाएगा, पूरा टाइम बचेगा, पूरे मार्क्स मिलेंगे. राइट? we'll just have to do this simple thing very very carefully and very methodically very well. इस पे अगर कमांड है तो CSAT में प्रॉब्लम नहीं आती. whatever topics we'll study in the future, though for all those topics this chapter of arithmetic will form the base. okay? ये अच्छे से कर लेंगे, वो भी आराम से हो जाएगा, बहुत ज्यादा डिफिकल्टी नहीं होगी, फॉर्मूलाज बहुत ज्यादा नहीं होते. राइट? यस सुनील, दैट इज करेक्ट. आंसर डायरेक्टली इज डी. 2-4 क्वेश्चन बचे हैं, करें या फिर कल करना है? इफ यू आर टायर्ड देन वी कैन डू इट टुमारो. इफ यू आर नॉट वी कैन डू इट टुडे एंड देन गो होम. इफ यू वांट टू ट्राई एट होम एंड देन वी कैन अटेम्प्ट टुमारो, दैट इज आल्सो फाइन बाय मी. यू गाइस टेल. क्या हुआ? खत्म होगा? नहीं ना? ओके. लावण्य सेइंग टुमारो प्लीज. कल करना है? आज करना है? नहीं करना है? देयर आर डिफरिंग व्यूज. कल करते हैं. आई हैव द वीटो. बट ट्राई इट ऑन योर ओन फर्स्ट सो दैट कल हमें कम टाइम लगे. I should not have to give you more time tomorrow to solve. If you attempt it at home, 2-4 ही प्रॉब्लम से, बहुत ज्यादा नहीं, 2-2 मिनट देना है हर क्वेश्चन को. उससे ज्यादा लग रहा है कोई बात नहीं, कल कर लेंगे. डोंट 1 घंटा यही कर रहे हो घर जाके, ये मत करना प्लीज. दिस इज CSAT, दिस इज क्वालिफाइंग पेपर. मेन अपना फोकस मेंस पे अपने होना चाहिए. ऑप्शनल्स, एथिक्स एंड ऑल, मतलब वट एवर यू वॉन्ट टू स्टडी, मेन फोकस शुड बी ऑन दैट. हियर यू कैन गिव 2 minutes, 3 minutes to each question. That is all. ठीक है? We'll meet tomorrow 8 AM. Tomorrow is very 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 important chapter of prime factorization. Please don't miss tomorrow. Prime factorization is very powerful tool when it comes to calculating divisible. When it comes to commenting on divisibility, calculating remainders, finding out LCM and HCF in one step, and prime numbers, as you might know, forms the basis of all our cryptography. That also I'll talk about something about that tomorrow. But don't miss tomorrow's class. Prime factorization is fundamentally important for arithmetic chapter. So don't miss tomorrow's class.